Hey, what's up? This is Madan sir here, and I'm doing next topic from alcohol, phenol, and ether, and we are almost like close to 60-70% of that chapter. This is really very important chapter I want to do, and I want to do each and every topic so that anyone else out there who is regularly watching my lecture, they really get to know and they really get the help they are expecting. Anyway, so what topic today I'm taking is dehydration of alcohol. So I'm going to brief you about all that that I'm going to describe you right there. Dehydration of alcohol means heating an alcohol or treating an alcohol with an acid, concentrated acid, maybe H2SO4, maybe H3O4, and maybe any protic acid. So if you heat an alcohol with a protic acid, water is released. And because water is coming out, so alcohol transform into alkene. So this conversion where alcohol is transformed into alkene, this is what called dehydration of alcohol, right? Or you can also call it dehydration of alcohol. So the thing is, what are the equations, and that's going to something very important. And another very important thing is that you have to have a mechanism of this dehydration of alcohol. So that's also very important topic coming up. So let's start that. Okay, so like I said, our topic is dehydration of alcohol. So I'm just giving the topic and explain you dehydration of alcohol. So this is what our main topic is. Let me define it a bit. When alcohol is treated with a protic acid, it loses a molecule of water to produce alkene. That's the defining part. Now the question is, what are the chemical equations and what is the mechanism? So I'm coming to that, but I just let you know, like it said, when alcohol is treated with a protic acid. What is a protic acid? An acid that donates proton, like H2SO4, H3PO4 and all that. So in presence of protic acid, alcohol dehydrate means loss water and converts into alkene. Let's take the simplest example here. This is ethanol, right? One of the very common alcohol we do know. And when alcohol is heated at some 443, I'm not sure because I have serious problem with learning. So this might be around 443 Kelvin temperature, and when it is heated with sulfuric acid, what happens? You have to understand the mechanism here, right? So you have hydrogen everywhere, there and there. So from one carbon, the hydroxide group breaks out. So this will come out as a negative charge. Carbon become a positive charge. But because carbon become a positively charged, so when the adjacent carbon hydrogen bond is broken, the electron shift towards the carbon. So this way, this hydrogen comes out as a positive and this carbon become a negative charge. So what I'm going to do, I'm putting them together, this negative charge with the positive charge of other one. So this comes out to be water. So one molecule of water is formed, and as you can see, there is positive charge on one of the carbon and negative charge on one of the carbon. So this means that the carbon is electron rich, this carbon is electron rich as compared to this. So the extra pair of electron this carbon has converts into a double bond. So this is how this one converts into alkene. Right? If you go through the reaction mechanism, this becomes really easy to you. And that's what I'm trying to do. Almost every equation I have tried, I'm trying to make it, that simple. So I hope this has helped you. So this is how you get your first reaction, right? This is actually primary alcohol. Now let's take another example where the alcohol is secondary. The alcohol is secondary. I hope you understand why it's secondary, because it has 2 carbon in the adjacent. So now you probably understand that a secondary, alcohol has a higher stability because it's more towards symmetry. So in that case, if you are using a weak acid, you have to understand that if you are using, so this comes out to be 440, right? And that very same thing happen. What you have to do, 1 molecule of water is generated as a byproduct, and other product, you can place the double bond either here or either here. So you get a propene. You get a propene. If you need to place the hydrogen, you can place it like that. So this is what the, product is. Now the question is, because this is a secondary alcohol and a secondary carbocation has higher stability as compared to primary, therefore this reaction takes place at lower temperature. This reaction takes place at lower temperature and in presence of a weaker acid. You have to understand why this reaction is taking place under a lower temperature and in presence of a weak acid, because the secondary carbocation is more stable. Let's take the tertiary one like that. Now you do understand that if this was 2 degree, this must be 3 degree then. So if a tertiary alcohol is undergoing, dehydration, so this will require, even less temperature. I don't remember that. I'm guessing around 338 Kelvin or something over there. And this require even a weaker acid. A weak acid like H3PO4, H3PO4, but this time the temperature has to be further lower. Now this, the product is absolutely same going to be here. So H2O, and other one is going to be, you have 1 carbon there, up there, because it was up, so I'm placing it up there. So what will happen? You can place the double bond either here or here or here. They both, every way it's going to be same. So I'm placing right here, right? I'm placing right here. So this is the product. Now look at the 3 equation here. They are very, very important information. When the alcohol is primary, it requires a stronger acid and a stronger condition. When the alcohol is secondary, it requires a weaker acid and temperature is slightly lower. But when the alcohol is a tertiary, which is more stable because it has a tertiary carbocation, so the reaction is taking place even at lower temperature, furthermore lower temperature, right? Because tertiary carbocations are more stable than secondary and than primary, right? So there was very important information, I just told you. So I hope you have understand what dehydration means here. In case you are, looking for some other example, I'm doing one more example where I will be taking more number of carbon. Let's take something like this one. This is your alcohol, right? And okay, and what you have to do, you have to use a weak acid. Why weak acid is required? Because this is a secondary carbon. So it is more stable. So the temperature is going to be something, like maybe around 400. I'm not writing the exact because I hardly know what that is. So around 400 Kelvin. So what you have to do, or you better place it like, heating it. So just place the symbol of heat. So what will happen? There is a problem in that it will produce 2 results. One double bond may be, either here, either double bond is going to be here or double bond is going to be here, right? So because there are 2 possibility of the product. So one is going to be H2O and other is going to be this one, and another one is going to be this one. Now, important thing is that this is a minor product. Why? Why it's minor? Because it's unsymmetrical, and this one is a major product. Because it is more stable, and this is less stable. If you want to know the reason why this is less stable, because position of the double bond is, according to set Jeff's rule. Let me repeat back something from the chapter 10. Do you remember set Jeff's rule? Set Jeff's rule says that if alkene is formed, then the alkene with larger alkyl group on either side of double bond is more stable than the one without. So this one is having equal number of carbon on either side, but this one has a 3 and 1. So this is going to be a minor one. This is going to be a major one. So this is how you can do any other example of dehydration of alcohol. So the topic I have now is mechanism of dehydration of alcohol. Dehydration of alcohol. Again, this is really important. So just pay attention to what I'm going to do. The first step is it's called protonation of alcohol. Protonation of alcohol. Where what happened? An alcohol like ethanol, because there was acid present and acids have a proton, so this react with the oxygen and a bond is formed between them. So this form a protonated alcohol. This form a protonated alcohol. So I hope you have understood. In case you need a further more expansion, you can see like that. So I hope it's easy. What happened here? This hydrogen ion has come from the acid, maybe sulfuric acid or phosphoric acid, and that hydrogen being electron deficient, it reacts with the oxygen because it has 2 pair of lone pair, and it forms a protonated alcohol. So this is the first step here. You can also write it formation of protonated alcohol, right? Okay. So in this step 2, what I will do here, just pay attention. I will, this is called removal of water, or you can also call it like formation of carbocation. Formation of carbocation. Let's see how this happens. I will, what you have to do, this bond between carbon and oxygen undergo cleavage. So this way, what happened? Water comes out. This comes out as water, and this become a carbocation. This become a carbocation. So this is your carbocation, right? And in the final step, what happened? This carbocation undergo further deprotonation. So let me repeat back. The step 3 involves deprotonation of carbocation. So how this reaction take place? These two are exactly our chemical reactants. So what I'm going to do, I am taking them in the same manner. There was no carbon, there was no hydrogen, and plus H2O. So if you understand, what will happen? What will happen if any one of the bond from the adjacent carbon break? Suppose I am breaking this bond. So what will happen? This bond cleavage will result electron moving towards carbon. So this hydrogen will come out as a positive charge, and this will become a negative charge. So what I am doing? This H plus will react with H2O, and this become H3O positive. H3O positive, right? And the remaining two, if you can see, this was negative charge. Don't take it like something else. So this was a positive charge, this was a negative charge. So these two carbon, this is electron rich, this is electron deficient. So they together form a double bond between them, and that's how an alkene is formed. That's how an alkene is formed. Just take a look to that and then let me know. So that is the 3 steps of dehydration of alcohol. I hope this was not very difficult and was also very interesting at the same time, right? So, these are some of the very important things. Let me repeat back. What I just did was, the main topic was dehydration of the alcohol, right? And what dehydration of alcohol means? Removal of water when alcohol is treated with an acid. If the acid is a stronger one, the dehydration becomes easy. But it also becomes easy as you take on, secondary and tertiary. Because tertiary alcohol has tertiary carbon, and a tertiary carbon is more stable than primary and secondary. So if you go back and check out the initial part, you will see that a tertiary alcohol require less vigorous condition like lower temperature and presence of weak acid in order to dehydrate itself, and then it convert into alkene. While a primary one needs a stronger acid and higher temperature, right? Because a primary has only a primary carbon has less stability as compared to the tertiary. So what you need to do, you need to go and check out everything, because this is really something important, and I will do next topic in the next video. Right now I would say, take care and just work hard, because there's nothing you're going to get very easy. You have to put your effort into it. If you are not from that, from a family where doesn't matter if you study or not, if you have a strong background, if you have a strong financial background, you definitely get the help anytime you need. But if you are from the middle class family or from a lower strata, this is where you need to put every effort you have to, and these are some of those steps that will take you higher and higher. So I would say work hard, don't leave it, don't give up, because giving up is not the only solution. Those rich, those who are born with silver spoon or gold spoon, I don't know what that proverb is, so they can leave it and they can enjoy their life the way they want. I have seen people from that league, but right now I'm talking about those who need it, right? Those who they need to work really hard. If you work really hard, you feel the kind of satisfaction. I tell you what, very simple instance, for last 3 months I'm trying to make 1 lecture every day. And the day I don't make it, I feel like, today I missed something. Why? Because this is where I feel the pleasure. This is where I feel like, I'm complete. I'm doing something, right? I'm putting my effort into something. How good or bad this is, it's all up to you. You decide and you let me know. I'm bad, okay, right? I will improve myself. I promise I'll improve, but I know I don't need to improve because I've worked so hard. Right? Not every two individual is the same. So I would say just keep working hard, because hard work has no substitute. Hard work defeats everything. Hard work and dedication, and they are a brain. You have your brain. You are a student of science, you have a brain. So if you have a brain, 2 more things required: dedication and hard work, and you're going to do whatever you want to do. Right? I don't want to give that lecture to you again, because I've been doing in some other lecture as well. Anyway, thanks for watching. Take care, and take care everybody out there, right? Not just you. Thank you.